In this video, I am going to present the C coding of 8051 to interface with 16:2 LCD monitor. So in my previous video, the theory regarding this interfacing of LCD with 8051 is completed. So before going to start this video, first watch that video and then continue. Okay. Now let us start the presentation. So, interfacing of LCD, we are going to interface the 16:2 LCD and the different pins and how to connect, which have been completed in the earlier video. And these are the data to be sent on the data pins of LCD to execute certain commands instead of sending characters. The procedure. Now coming to coding. So first we need to give the instruction hash include regx51.h so that the program can identify what are the registers that are existing and the peripherals that are existing in 8051 microcontroller. And SFR L data equal to 0x90. So this is corresponding to port 1. So whenever L data we are saying, it indirectly means port 1. And the different pins of LCD are connected to different pins of 8051 microcontroller. So instead of remembering the pin numbers, we are assigning the connection that we have given on the LCD pins to microcontroller. We are setting them. So suppose RS pin of LCD is connected to P2.0 or 0th pin of port 2 of 8051. So like that, RW pin is connected to first position pin of or P2 cap 1. Enable is connected to P2 cap 2. And busy pin is nothing but D7 pin is connected to P1 cap 7. And we have written functions for interfacing LCD because we are sending data using the data pins that are available on the LCD. So the data we are sending, is it the character to be printed on the LCD or is it a command to be executed? So our program has to differentiate them. So based on that, we need to select where the data is to be stored. If it is a data, if we are sending a character that is to be printed, it will be stored in the data register. And if it is a command, like clear the display, move the cursor, turn on the cursor, turn off the cursor, move cursor right, all these are the commands, not the characters. Whenever we are sending such kind of data on the data pins, that data need to be stored in command register. Okay. So the variation will be identified in these two functions. And before sending data, we need to verify that our LCD is ready or not. Means we have placed the data on the data pins. The LCD takes some time to latch the data into its internal registers. So meanwhile, it will be busy. So there are two processes here. We can provide a fixed delay after placing the data, or we can wait until the LCD gives the instruction that it is free or it is busy. So if you are using this LCD ready function, we are efficiently using the time of the LCD. Okay. And for delay, we are using the standard delay program. Now coming to the main program. The main program, first we need to initialize our LCD. So there are different kinds of LCDs available. So which kind of LCD you are using, you need to specify, which is not a data to be printed. It is a command that we are giving to the microcontroller that LCD is this kind. So LCD CMD, we are sending a command. So the value which we are sending to the LCD is 0x38. So which is corresponding that the program or the LCD which you are going to interface is operating in 8-bit mode, and it is a 2-line display and each character is having a 5 by 7 matrix. Okay. And the next command is 0x0e, which we are sending, which means display cursor on and cursor on. So first empty display will be there, and then the display will be powered on, and on that cursor will be displayed. LCD command. Suppose for example any data is existing in the registers earlier, it may be displaying in the LCD monitor. So we are clearing the display before which we are going to place any new data. And now we are moving the cursor to the next character. We are moving the cursor to the right, and then we need to start from first position. LCD, two lines are there. First line, first position, whose address is 08 0x80, but we are giving 0x86, which means here 0x80 means here. Okay, but what we are saying 0x86. So this position corresponds to 80, 81, 82, 83, 84, 85, 86. So whatever data you send or whatever character you send, it will be displayed at this position instead of here. Okay. Now all these are commands. Till now we haven't sent any data. So the data which we are going to display is MDE, one after the other. So data character M, data character D, data character E. So here we are just calling the functions, where we are specifying that LCD command is a function which is sending a data related to command. LCD data is a function which is corresponding to data to be displayed. So whatever 38, 0E, 01, 06, 86, all this data we are placing on the data pins of LCD, but nothing is going to be displayed. Out of these numbers, nothing will be displayed. But LCD data character M means this letter M will be displayed. LCD data D means letter D will be displayed. Data means what is the data which we are sending is for display. Okay. Now we'll see what are these commands. LCD command, LCD CMD, LCD data. What are these functions? First, LCD CMD. So we are sending a value using this function. So this function is receiving a character value. LCD ready. Before sending either it is a command or data, we need to verify that our LCD is ready or not. So for that purpose, we are calling the function LCD ready. And then whatever data we want to send, we need to place on the data pins of LCD. So the data pins of LCD are connected to port 1 of 8051. So our port 1 is nothing but L data. So load data, for simplicity we have given the name load data. So whatever value you are sending here, it will be placed on your port which is connected to the LCD. So here 0x38 LCD CMD 0x38. So whenever that function is called, 0x38 will be loaded on port 1. Okay. Then RS equal to 0. So RS is nothing but, RS is nothing but P2.0. So the 8051 in 8051 microcontroller, pin 2 cap 0 will become 0. Means which is connected to RS pin of your LCD. So whenever RS pin of your LCD is 0, the data what you are placing on the data pins, it will be stored in the command register. So the LCD understands that whatever value I am sending, which is 0x38, is not the data to be displayed on the screen. It is a command. And RW equal to 0. RW means write operation. So we are writing. The microcontroller is giving data to LCD. EN equal to 1. EN equal to 1 means you are loading the data on the data pins. But whenever you are enabling it, then only the data will be latched into the internal register. So we are giving certain delay and again making en equal to 0. So in this delay, the data will be latched, and whenever we are making en equal to 0, the new it will not take any data until this enable is made again. Okay, so whenever LCD command function is called, we are checking whether LCD is ready or not, placing the value to be loaded on data pins of LCD, and giving the information that it is a command by making RS equal to 0, and we are sending data, therefore RW equal to 0. After placing data, we need to enable to latch the data into the internal register, and again making enable equal to 0. In the same way, if we are sending a character to be displayed, the entire instructions will be same, except whatever value you are loading on L data, now it is to be stored in data register. So instead of making RS equal to 0, here we are making RS equal to 1. So whenever this function is called, whatever character you are sending here, it will be displayed on the LCD monitor. LCD ready. So here busy equal to 1. What do you mean by busy here? Busy equal to P1.7. So port 1 pin 7 is connected to the busy pin of LCD. We are placing 1 on it, and it is not the data, so it is 0. It is a command. Here we are not sending data to the LCD. We are checking whether LCD is ready or not. So the information will be coming from LCD. LCD is sending signal, I am busy or I am free. Whenever LCD is busy, that bit will be 1. Whenever LCD is free, that bit will be 0. So we are writing while busy equal to 1. So we made it 1. Whenever the LCD is processing, this will be in high state. Okay. Whenever the process is over, busy becomes 0. Okay. So while busy equal to 1, enable equal to 0 means it will not accept the data. Earlier we have already seen en equal to 1. Enables means whatever data you are placing on the data pins, it will be latched into the internal registers. So if your LCD is busy while busy equal to 1, enable equal to 0 means even the data is placed on the data pins, it will not be latched to the internal registers. Okay. So again enabling and again checking. So this loop will be repeated until busy equal to 1. Whenever busy is equal to 0 means LCD is free, it will come out of this loop and the function will be over. So whenever it is called, this function is called, what happens? The program control will be in this function only until busy equal to 0. Means whenever your microcontroller is busy, the function will be running continuously. Whenever your LCD is free, this busy bit becomes 0 and function comes out of the loop. So here before LCD data or before LCD command, first we are calling this function. So whenever this function is called, the program will be here only until your LCD is ready. Okay. So once LCD is ready, you can place the data. It may be a command or it may be a data. Okay. And the general delay function. How many milliseconds you want, you send item as the variable. So if you place 1 here, 1 time it will be running 1 millisecond. If you place 2 times this will be running 2 milliseconds. Okay. So thank you. If you have any doubts, please post in the comment section. I will respond.